This is the fourth video in a series of videos on solving trigonometric equations. We're now going to look at a slightly different type of question. Consider the question where we want to solve sine x plus cos x equals 1. Now, I could go and divide by cos, but that complicates things. I could try to square both sides. All variations tend to just complicate rather than simplify. We need another tool to be able to answer these questions, and we sometimes refer to this as transformation of the trig functions. So in this case, the transformation that's required is this particular one, where if I have a sine x plus b cos x, then that is the same as r sine x plus alpha, where r is the square root of a squared plus b squared, and alpha is inverse tan of b on a. Now you might be wondering, how is that possible? Where does this come from? So let's have a quick look and see if we can prove that this relationship works. So let's start with our first line. So we have a sine x plus b cos x, and we are saying that that's an identity to r sine x plus alpha. So we're going to start with the identity, and if I can find a unique r and alpha that makes this identity true, then we're set. I'm going to work on the right hand side. I'm going to expand that. So I have r, expanding sign gives me sine x cos alpha plus cos x sine alpha. That can be rearranged slightly to read r cos alpha sine x plus r sine alpha cos x. So for this identity to be true, r cos alpha must equal to a, and r sine alpha must equal to b. Well, that tells me that cos alpha is a on r, and sine alpha is b on r. I can draw a right angle triangle showing that relationship in terms of alpha. There's my r, there's my alpha. Cos is adjacent over hypotenuse, and sine is opposite. So you can see that by Pythagoras, r squared is a squared plus b squared, and by our trig relationships, tan alpha is b on a. So our initial identity is true if these two conditions are true. So I can use this identity to now go back and solve the original question. Remember, r squared is a squared plus b squared, and tan alpha is b on a. So let's go back to our problem. In this case, the coefficient of sine is 1, the coefficient of cos is 1. So my a is 1, my b is 1. Therefore, r is square root of 1 squared plus 1 squared, that would make it 2, and alpha is inverse tan of 1 on 1, and we know again tan of pi on 4 is 1. So our original question can now be rewritten as, so we had sine x plus cos x as root 2 sine x plus pi on 4. Now that's meant to equal to 1. So instead of solving sine x plus cos x equal to 1, we are going to solve root 2 sine x plus pi on 4 equaling 1, resulting in sine x plus pi on 4 equaling to 1 on root 2. Again, I need to look at my domain and the quadrants. So assuming our domain is between 0 and 2 pi, since I'm working with x plus pi on 4, that would mean the domain is between pi on 4 and 2 pi plus pi on 4. And the quadrants I'm looking at for sine would be first and second. Alright, so let's solve this. X plus pi on 4, 1 on root 2, that would be pi on 4. That would be in my first quadrant and falls within my domain. The next would be in second quadrant, so that would be 3 pi on 4, and I go beyond 2 pi to 2 pi plus pi on 4 as a solution. Take away pi on 4 from both sides, and that leaves me with 0. 3 pi on 4 minus pi on 4 is 2 pi on 4, or pi on 2, and 2 pi. Okay, so this relationship we had up the top in green is very important. There are 3 others, so I am going to list the other 3, and I highly recommend that you try to reproduce a similar explanation of how the relationship works as I have here. For all cases, r will end up being square root of a squared plus b squared, and alpha will be inverse tan of b on a. So let's quickly list those down. So we had the plus case. Let's look at a sine x. I might write the first one down. Plus b cos x equals r sine x plus alpha. Then we will have a sine x minus b cos x equaling r sine x minus alpha. A cos x plus b sine x, so cos first, sine second, is r cos x minus alpha, and a cos x minus b sine x is equal to r cos x plus alpha. The other things to remember, in all cases r is square root of a squared plus b squared, and I might write tan alpha is b on a. How do we remember these? Okay, so if you think of your trigonometric identities, I'll just go back to here. We have a plus here for sine x between a sine x and b cos x, and when we expand sine a plus b, we end up with a plus. So we know that a minus and minus, when I expand sine x minus alpha, I'll have a minus in between, so that will match. We know that when we expand our cos a plus b, we end up with a minus. So for the plus, we end up with a minus, and for the minus, we will end up with a plus. When we have cos, our relationship is cos. When we have sine, our relationship is sine. So sometimes students will question this and say, well, a cos x plus b sine x can be rearranged to be the same as this. And yes, it can, but then you might lose some solutions in the process. So it's not advisable to take that approach. It's best to know all four relationships and apply the right relationship for the right question.